broadcast is now starting. All attendees are in listen-only mode.
We're going to begin the webinar shortly. We're just going to wait a couple more minutes for a few more folks to sign on. Louise and Mary, can you mute your mics just for now, please?
Yep.
Thanks, guys. Okay, welcome to PEI's Masterclass, Ice Core Science, Using Knowledge to Act. Thank you for joining us to learn more about polar science and education. My name is Betty Trummel, and I will be the moderator for tonight's class. Climate change is arguably the most urgent issue facing the planet and future generations. This masterclass will explore understanding evidence of past climate change from polar ice cores, as well as adaptation strategies being used by communities already being affected by climate change. It will also focus on how to empower our students, colleagues, and families to take action. The masterclass series is designed with two audiences in mind: educators who want to build their science knowledge and researchers who are interested in improving their science communication skills. This class will provide a deeper understanding of ways that scientists and educators can work together. You can learn more about PEI on our website, polareducator.org, and I've put this page up so you can see the various tabs on the home page of the PEI website. The Masterclass tab is particularly important because it's got your syllabus and all the other pertinent information about this class, and also information about previous masterclasses. PEI is a vital international network of educators and researchers aiming to provide a deeper understanding of current polar science. PEI represents trusted leaders working to inspire appreciation and knowledge of the polar regions, their connectedness to all Earth systems, and importance to all humans across latitudes and cultures. One of the ways that PEI is working to meet these goals of our vision statement is to sponsor master classes like this one, focused on the needs of a dual audience, educators and researchers. We're excited to present the class tonight, and we'll have another masterclass scheduled for later in 2019. Some of our previous masterclasses have been ice sheets and sea level rise. We've got climate impacts, looking back to the future using paleoclimate data to understanding Antarctica's ice sheets, what will happen to penguins and other Antarctic animals, intro into Antarctic marine systems, carbon cycling in the Arctic, and climate change in the bottom ocean community. Tonight, if you've got questions for our presenters, you can write your questions in the question box. We'll post some of them at the end of each of the presentations. Your questions will only come to the moderators. We'll try to fit in as many as time allows. Any unanswered questions from the webinar or new questions can be posted and answered in our Google group discussion, which will take place from the 4th through the 15th of March. So I'd like to, my great pleasure, to introduce our first speaker, Dr. Mary Albert. Dr. Albert is the Executive Director of the U.S. Ice Drilling Program and Professor of Engineering at Thayer School of Engineering at Dartmouth. At Dartmouth, she teaches classes on climate change and engineering at both the undergraduate and graduate level. And the current research that Dr. Albert and her graduate students are addressing involves climate change in two ways: understanding evidence of past climate from polar ice cores, and also developing adaptation strategies and frameworks needed for communities under current climate change. Our second speaker tonight will be our educator, Louise Huffman. Louise has had many years of experience with polar science and education outreach, and she completed a full career as a well-respected and award-winning classroom teacher. Currently, she's the Director of Education and Public Outreach for the U.S. Ice Drilling Program, a National Science Foundation-funded program at Dartmouth College. One of the highlighted EPO programs for the International Ice Drilling Program, is the School of Ice, held each summer for faculty teaching at minority-serving institutions. Louise is responsible for creating resources, activities, and labs to transfer ice core science concepts to classrooms. So I'm going to transfer the screen to Mary, and she will get going with the presentation.
Thank you for inviting me to talk tonight. Can you see my screen?
I do not see it yet. Let me see.
How's that?
Now we can see it.
You can see it. Okay, great.
I can't see it, but that's okay.
Okay. All right. Thanks, everybody. And thanks to everybody tuning into this. I'm going to talk about tonight, my title of my talk is Ice Cores, Climate, and You. And you meaning us, all of us on this planet Earth. Oh. For some reason. Okay. The overview of this talk is to look at how we can measure climate indicators, how we know what's going on at the present, and how we can know from the past, how does that set a context for the present. We're going to focus in on just a few things in this talk, and the main thing is the carbon dioxide in the atmosphere, a greenhouse gas. We hear about it in the news every day. We are worried about it, and we're going to talk about how the atmosphere today, is it typical of the past or not? We'll rapidly then get into discussions about renewable energy, because the carbon dioxide and other greenhouse gases coming from fossil fuels are a problem of the present. Why are some people using renewable energy? Some are and some aren't. And how can individuals make a difference? We know we have to change. How can we adapt? So it helps to step back and look at our Earth as a system of systems, with the oceans that circulate around the world and the atmospheres that is always circulating and overturning on many scales, small scale and large scale. And the interactions between the atmosphere and the oceans. We know that as climate change is happening now and the global temperature is going up, although the global temperature is rising, it will affect different it'll have different impacts in different locations, largely due to the fact that the oceans and the atmospheres are always moving systems of fluids. Their connectivity means is that changes in one part of the system will affect other parts of the system. So to understand how we put the present in a context of the past, we have evidence. We look at different pieces of evidence from the past. From tree rings, we can go back hundreds of years to look at precipitation patterns and to understand what was what was the environment when a tree was growing in a certain place. Ice cores in the center, we can go back to hundreds of thousands of years to look at what happened in the past. To go more distance in the past, into the millions of years, we need to go to ocean sediment cores. Each piece of evidence has its own clue to tell in its own way. I'm going to talk about glaciers and ice sheets, the two ice sheets on planet Earth are the Greenland ice sheet in the north in the Arctic and the Antarctic ice sheet in the south. In the middle is me standing in a snow pit. I've stood in snow pits both in Greenland and Antarctica. You can see that I'm down, and at the top of the pit is just out of the top of the picture. But when you're standing in the snow there, you notice right off the bat how the snow looks layered. It's not all uniform. And we understand that at the top of the snow pit was snow that just fell this last summer. Below that, it was a darker band that fell the winter before. The lighter band below that is the summer before that. The darker band, what I'm pointing, is the winter before that, and so on. The further down you go, the further into the past you go. And the interesting thing about ice cores and ice as evidence is that in areas where we get a lot of snowfall, high accumulation area, it has really high resolution indicators or evidence from the past. So much so that even although this snow becomes squashed and compacted as it turns into ice, even as it is solid ice, down in the lower right-hand corner, you see an ice core, you can still see the layering. And we know that that is evidence of what the physical processes were that are happening at that time. The ice core in this picture has an additional dark band that you can see, and that was, this is an ice core in Antarctica. That band was when some local volcanoes went off. So for the year or two, the volcano ash was settling. You can still see that in the ice core. But looking on the left-hand side, we can see that conceptually, when we drill an ice core down through several miles of ice, whether it's 2 miles of ice in Greenland or 3 miles or more in Antarctica, we start at the top, go down through snow where there's lots of air in the snow. As we go deeper, the snow becomes more and more compacted, and we call it firn. It's porous old snow. As we go deeper still, it becomes more and more compacted until finally down towards the bottom, well, actually down about 100 meters or so, it becomes compacted into solid ice. At that point, the only air that's left is trapped in bubbles in the ice. So as we know, at the top is the present time. As we go down, we go deeper in time. To get pieces of artifacts or evidence of old air, we go look to the bubbles down in the deep glacier ice. Center picture is a picture of a drill that we used at South Pole to go down into the ice. You can see that the drilling operations, when you go deep in the ice, it requires a major facility like this. If you're only going to go back 10 or 20 years, you can go out with a hand auger or something much less. But scientists are climate detectives. They identify a question to ask. They drill an ice core that will give them answers to that question. We know that evidence from the past can provide a context for the present. So for this talk, we're going to talk about carbon dioxide. And as we know, we are increasing carbon dioxide in the atmosphere from emissions, from power plants, from our automobiles, all the emissions. And we understand very well from the physics that the more CO2, the more methane, the more greenhouse gases we put into the atmosphere, the warmer the atmosphere gets as a whole. So what is the CO2 concentration in the atmosphere now? Write it down. Do you have a pencil next to you? What is it now? And how do we know that? We know what CO2 concentration in the atmosphere is now because we can go outside and measure it. And scientists have measured it since the 1950s, and they've kept records of it. So this particular graph is from Mauna Loa, where scientists have measured it since before 1960 up to the present. And what is the CO2 in the atmosphere now? We can see that it's about 410 parts per million. So we can see that it's been going up since the late 1950s, and it's now at 410 parts per million. So is that typical of the past? Is this an unusual time? Or has Earth always been doing this? How do we know what it was in the past? How do today's levels compare to the past, and how do we know about it? We'll put our detective hat on. We'll go and drill ice cores. A lot of the greenhouse gas measurement ice cores are from Antarctica. And on the left-hand side, you can see our ice core there as it was taken out of the drill. If we stand that ice core up, like in the center, we can still see some of the layers in it. And if we section it and look very closely at it, blow up just a bit of that ice core, we can see that the ice in some depths contains bubbles. Those bubbles contain air. And the composition of that air is the composition of what was there when that bubble got formed in the ice. So as we go deeper into the ice, we go further into the past. And as we go further into the past, we can look at these bubbles to understand what the composition of the atmosphere was. So here's a graph from an ice core that was drilled in Antarctica. If we look at the time scale at the bottom, the current time is at the right, 0. That was when the ice core was drilled. If we go to the left, it goes back 200, 400, 600, 800,000 years. This graph goes back 800,000 years. And what does it show? In red, we see is a graph of carbon dioxide. Those were measurements from bubbles in the ice core. In the green is methane. That was also measured from the same bubbles in the ice core. And at the bottom, we see a black graph that is temperature. That was taken from isotopes in the ice itself. Scientists have done an amazing amount of detective work to figure out how to detect this and how to record it. We can look at this data and we can see that over the last 800,000 years, there are patterns. Climate has varied over 800,000 years. Yes, it has. And the CO2, methane, and temperature seem to go together. They follow very similar patterns. If we look at our CO2 that we're looking at now, it's varied from about 180 parts per million up to 280 parts per million, down to 180, up to 280, down to 180, up to 280 over 800,000 years. And we can look at the right-hand side, we see where it is now. It's off this graph, so I had to draw it in. Remember, we're now around 410 parts per million. How does the present compare to the past? We're way beyond the evidence we have from the last 800,000 years. If we look at the carbon dioxide and the temperature and we compare them, we see that we follow a similar trend. So that the warm times in the past when CO2 was at 180 are called interglacials. They're times when, like the present, when the ice sheets were melted way back. And on the right-hand side of the graph here, you can see a Google chart of the globe. In the northern hemisphere, you see the Greenland ice sheet up there. We are in an interglacial now. If we go into the past and see when a colder period, down when CO2 was around 180 parts per million, what did the northern hemisphere look like? It looked like this depiction of the globe with the Laurentide ice sheet covering the entire Arctic, all of Canada, and a lot of what was northern US today. That change in temperature was about relative 8 to 10 degrees at that point where it was measured. So changes in temperature of the Earth system, the Earth is very sensitive to that. If we look at the temperature where we are now, we're way above where it was during past interglacials. We can expect rapid warming. We know that when the climate is warm, these massive ice sheets melt. Where does the water go? It goes into the ocean, and it causes sea level rise. If the Greenland ice sheet in the north melted, sea level would rise about 6 meters. If the Antarctic ice sheet entirely melted, it would take a long time, but sea level would rise about 73 meters. That's a lot. We know from the physics that climate is warming. We know from the physics that the melting of the ice sheets will cause sea level rise. So let's think about this. It makes us wonder, if we look at this past in the past, we look at the current interglacial there on the right, and we see that there was an ice age before that, where that yellow arrow is pointing. If we go further into the left, further into the past, about 113,000 years ago, that was the time when the last interglacial was. the last time it was this warm? What was the evidence of sea level at that time? Where did the water come from? Well, a couple of years ago, an international group of scientists drilled an ice core called the Neem ice core in northern Greenland. You can see it in red here. In northern Greenland, it was drilled. The ice core was analyzed, and one of the results was that from that core was surprising. We found out that the Greenland ice sheet during the last warm period, the Eemian, it contributed about 2 meters of the 6 to 9 meter level rise that happened during that time. We know about the 6 to 9 meters from geologic evidence. We know how high it was in the last warm period. But Greenland only contributed about 2 meters of that. This means that much of that sea level rise probably came from Antarctica. All eyes are on Antarctica now to see where the next sea level rise was coming from. But we know from our daily lives that sea level is already impacting us today. Around the world, there are many severe instances. Here's a simple instance from not very far away from where my friend Louise Huffman lives, Miami. The streets are flooding in Miami on days when it's beautiful weather, not driven by a storm or rain, sunny skies. But on a king tide, the streets in Miami flooded. And I'm here to tell you that the engineers did not plan Miami to have the streets flood on a high tide. Do you think it'll be a long time? Now they flood on a king tide, which is an occasional very high tide. How long do you think it will be before the streets of Miami flood on every high tide? What will be the source of the next big sea level rise? Scientists look for evidence. An international group of scientists is now looking for evidence that all eyes are on the Thwaites Glacier in Antarctica. So let's look at Antarctica. In the top left there, you can see a cartoon of Antarctica. We understand is a massive continent. Footprint of Antarctica is much larger than of continental United States. And the ice covering all of Antarctica is many kilometers thick. On the right, you can see what Antarctica would look like if you took off those thousands of kilometers of ice from the top of the continent. And you see deglaciated Antarctica, what it looks like. It has two parts, basically. The big part on the right is East Antarctica, massive mountain chains, huge volume of land mass. On the left-hand side is West Antarctica. It's more of a series of islands, more like an archipelago. Yet today, the ice sheet is covering all of that. West Antarctica is a marine-based ice sheet because it's so exposed to the ocean underneath. As you see in that red circle on the graph on the left, that there's a huge inlet and a big area in West Antarctica that is, the land is under the sea surface. This is where there's been a lot of evidence of the ice sheet moving very rapidly now from remote sensing evidence and others. We know that the ice is draining out of that now. In the bottom left, you see a cartoon from the Thwaites Glacier Group, an international study of scientists from Great Britain and the United States and elsewhere, all looking to see how fast is this sliding? Why is it sliding? Can we better understand the mechanics? Can we better model it? How much sea level will it cause? And how long will it take it? How fast will it come? All eyes are on Thwaites. This is hot stuff. Keep your eyes on the news in the next several years. Not too far away from the West Antarctic ice sheet where the ice is sliding into the ocean. On the left, you see a red dot called HD. That site is Hercules Dome. And if you look on the graph on the right, you see that Hercules Dome is up on the land, right on the edge of East Antarctica. It's a site where if the West Antarctic ice sheet had collapsed before, it would have still been there. It would have been a witness to the collapse of the West Antarctic ice sheet. The snow falling there would have been affected by the ocean, would have been affected by the atmosphere. We'd have evidence to understand what happened, what led up to it, how fast went it. Should we drill an ice core there? We hope so. Let's go back to Louise's house. This massive sea level rise we think is coming. There's evidence that it might be coming from Antarctica. But the water that comes from Antarctica raises sea level everywhere. Poor Louise, her house now, under 5 meters of sea level rise, isn't even on land anymore. Areas around Florida and around lowlands across the world, many cities are at danger of sea level rise. So what is going to happen here? Are we going to burn so many fossil fuels that we'll run out of fossil fuels before our glaciers and ice sheets melt? Here's a graph from the IPCC report in 2011, the special report on renewable energy. Even at that time, potential emissions from the fossil fuels that are still in the ground would raise the level in the atmosphere above 600 parts per million. What are we now? Oh yeah, 410 parts per million. What's normal? 180 to 280 to 180 to 280. We will not run out of fossil fuels. We have enough fuels to cook our planet. What about renewable energies? Are they a pipe dream? Do renewable energies have the technical potential to power our needs? I won't go into this graph, but you can read about it in the same IPCC report. Even back in 2011, the potential renewable energy exists. There is enough sunlight coming. There is enough wind blowing. There is enough ocean circulation. The potential is there. We need to harness it. We need to implement it. If we implement it, we can change our energy from fossil fuels and use more renewables. Sure, it'll take time, but we better get at it. There's an added benefit. Clean renewables have important health benefits. If you live near a coal-fired power plant, you're probably wearing a mask around when you go outside every day. Clean energy is healthy. So this urgency to reduce greenhouse gas emissions means that we must speed up the transition to renewables now. We all hope for policy, yet policy is too slow. It's too conflicted. We can't wait for policy. Let's think about energy. Energy goes through different stages of development. If we think about the energy that we've been using, here's a picture of early stage technology where humans learned how to burn fuels. They learned about combustion. They learned how to start a fire to provide their heat and to provide their light. If we look hundreds and thousands, in fact, of years later, as engineers have worked away with this, engineers have now figured out how to harness burning to provide heat, to provide light, to provide transportation. On the right-hand side is mature technology, hundreds of years of engineering development. I'm going to show you another picture of early stage technology. On the bottom left, we have early stage technology. That flat panel was motivated by scientists thinking and wondering how plants could use photosynthesis to create energy. Engineers and scientists have been able to figure out how to harness the power of the sun in a solar panel to create electricity. They figured out how to harness the power of the wind to create electricity. The two pictures in the bottom left are early stage technology. Engineering is only started on those. There's huge gains that can be made if we put our efforts into developing that. We can only imagine what it will look like in the future. But early stage technology plus future demand means opportunity. Opportunity to act on the energy transition. Not only we can use it, we can sell it, we can make it, we can start small businesses. We have opportunity to act on energy transition. The renewable energy depends on the local environment for its fuel. Sure, it's not the same everywhere. Everywhere is not equal in terms of solar power. Everywhere doesn't have wind, but we have evidence. Here's evidence from the United States. There's maps for other areas all around the world. In the United States, we see that the bottom left, the Southwest has huge potential for solar energy, clear skies and lots of sun. Here I am in New Hampshire, way up in the Northeast in cold, dark New Hampshire. And in the central United States, the Great Plains offer huge amounts of wind. We have these renewable energies that we can use to our benefit. They're there. Can we harness them? But even here where I live, in cold, dark Vermont, in the northeast of the United States, solar energy is saving homeowners and communities money. Right here, right now. It's a cold, dark area to live. Do we get enough solar to use for our house to save money? You bet we do. In the bottom left-hand corner is a picture of a very small town in Vermont. They put solar energy on their school. Are they all tree huggers? No. Do they want to keep the cost of school affordable? They sure do. They put solar on their schools. I have solar panels on my house. I have not paid an electric bill in 3 years. The energy transition is underway. Individuals are important to the energy transition. Yes, national entities are important. Yes, a policy is important, but you are important too. At home, start the energy transition in your home. It won't happen overnight, but plan it. How are you going to change to renewable energy for your transportation, for your heats, for your light? In the community, work with your neighbors. Shape a vision for the transition. How can you save money for your school buildings, for your town halls? Learn the facts about climate. Here are some terrific resources online. There's a lot online. In the United States, just released is the National Climate Assessment, made at a level comprehensible to all people. Globalchange.gov. Check it out, download it for free, read about it. There's a very important report that the IPCC recently put out, global warming of 1.5 degrees. What does 1.5 degrees really mean? What are the impacts? Read this. Have your students read it. Have them talk about it. What is climate what's gonna happen in the future? What's predicted? And then learn more about renewable energy and empower your students. Help them to design their projects. Help them to know that what's within their reach. Help them to vision themselves and their own energy transition. The Clean Energy Group has also has information about climate change and clean energy. Online, there are tools here, the Energy Technical Potential Toolkit. Let's play around. What can we do where I live? The bottom, the toolkit on climate.gov provides tools that citizens across the nation and elsewhere can use to envision how much sea level rise is going to affect their coastal town, how much rain they'll get in the interior, how hot will it get. These are important tools. They're available online for free for everyone right now. So in ice cores, we've learned ice cores from certain areas have really high resolution evidence about climate. I didn't have time to squeeze it in today, but we know ice cores from Greenland taught us the important lesson that climate could change from one temperature regime where it's wobbling around to a whole different temperature regime in less than 10 years. Climate shifts can happen abruptly in less than 10 years. Evidence from ice cores has shown us that CO2 to the atmosphere now, we're higher than we've been in 800,000 years or more. The technical potential for global use of renewable energy exists. We need to accelerate the transition. We need to implement it, start using it. Cost of renewables has dropped in recent years. The technology has developed. As it develops more, it's going to get even more affordable. And actions by individuals and communities are important in transition. We need to get going, all of us, right now. So Louise asked me to talk about some of the communication methods I use. I'm sure that you use also a lot of visuals to minimize words. Images, graphs, photos are worth 1,000 words. I found that it's really important when I talk to audiences to relate the content to their daily lives. What matters to them? Why is this important science so critically important? What are the many lessons we've learned from ice cores that affect our daily decisions? And I've learned that I should end on a positive, empowering note. As an engineer myself, I know that we can do better than we are now. I've harnessed the power of solar even in my cold, dark New England home, and it's saving me money. You can do it too. I want to thank you all for joining us today. I want to thank you for using evidence when you make decisions. The evidence is online at IPCC, climate.gov sites. Look at it and use it. I also want to thank the National Science Foundation for funding ice core science, broader ice science, and all sciences. We wouldn't be where we were today without NSF. Thank you.
Thanks so much, Mary. That was great. There haven't been any questions posted yet for Mary in the chat, in the question box. If anybody has a question, I'll continue to monitor that, and we can always ask them again at the end. If anybody has a quick question, they could type it in now. Otherwise, we're going to go ahead and switch to Louise and let her present her educational part of the program.
Okay, I'm ready as soon as you can see my screen.
I'm going to change it right now. Okie doke. It says waiting to view your screen. There we go.
Okay, so Betty introduced me earlier, and my name is Louise Huffman. I'm the Director of Education Outreach for the ice drilling program that Mary is the Executive Director of. This is my email, so at any time if you have questions for any of the ice core scientists, feel free to contact me, and I'm more than happy to find the person that can answer the question if I can't. So tonight, what I'd like to do is talk a little bit about some resources that are available, and also a little bit about the class that'll take place March 4th to 15th. We're starting it on Monday to give people, international participants, the chance to watch the recorded version, which will be up tomorrow. So tonight, these are the goals that I have. I want to talk a little bit about the ice drilling program's education website and let you know about those resources. And then talk about 3 different resources that I think are very important. The IPCC 2018 report, the National Climate Assessment Report, and Project Drawdown. And at the end, I'll also let you know where you can join the masterclass and download the syllabus. So this is what our website looks like. It's the Ice Drilling Program Education Outreach website. At the top, you'll see Home, Browse, Content, and then School of Ice, which is our program. We have a workshop in the summer for faculty who teach at minority-serving institutions, and I'm excited to know that some of those people, past participants and future participants, are on the call tonight. If you click on Browse All Content on this page, it takes you to a whole list of all of the activities and resources and labs that we have on the website. There's about, I think about 15 to 20 right now up there, and I'm adding things all the time. If you scroll down to the middle of the page of the home page, there are places for you to sort those activities for grades 5 to 12, college educators, and the public. And I just want to share one activity with you tonight from here. This is called Life Cores, and it's one that Julia Dooley, who's the president of Polar Educators International, developed with a couple of ice core scientists. But it'll show you how all of our activities are set up for you to use. Every activity has a list of materials and a preview. In this case, it talks about how students build a personal life core, and by doing that are introduced to techniques and vocabulary used by scientists as they study ice cores. Give some background for teaching it, and then key concepts, like in this case, that recent history is at the top of an ice core, and the deeper layers record older periods. And in this activity, the students would be building a time machine of their life through this core. It also talks about how repeated patterns can show cycles in the climate in an ice core, and also repeated patterns in a child's life. our activities are all aligned to the next generation science standards for U.S. educators. If you're in a state that is using the NGSS, the alignment is there for you. I found that this activity is great at almost any age, from early elementary students on up to our School of Ice people, that we've used this activity as an introductory activity. And so for those of you who haven't been to School of Ice yet and are coming this year, you're going to be getting a tube in the mail. So be ready for it. So let me talk to you just for a second about a couple of really important reports that have come out recently. The IPCC special report came out in October of 2018. It's the Intergovernmental Panel on Climate Change, and the IPCC is the United Nations body that assesses science related to climate change. And this was a really important report. The IPCC is the most up-to-date and comprehensive climate change report. It's an international report, obviously, through the United Nations. It's 91 lead authors and 133 contributing authors. The group assessed 30,000 scientific papers and made over 42,000 comments during the review. So what do we need to know about the report? There's lots of information in it. For tonight, I'm just going to mention one main thing. That is that the world has already warmed about 1 degree C since the middle of the 19th century, and the temperature may reach 1.5 degrees C by the middle of this century at the current rate of warming. And we're on track for a 3 to 4 degrees C rise. The IPCC report gave us a really dire warning with this. In the past, the groups have talked about, well, we want to keep that temperature below 2 degrees C, but this report came out and said we need to limit it to 1.5 degrees C. And to do that, it's going to require immediate action and still create climatic difficulties for the Earth, but the results will be markedly better for the planet than if we allow it to go higher than that. So when I heard this report, being in the climate change communication business, I actually was feeling pretty hopeless. I'll be really honest. I went, how in the world are we going to change from fossil fuel use to renewable energies? And they've attached, 10 to 12 years. And Mary had talked about abrupt changes in climate can happen in as short as a decade. So I was like, well, how are we going to do this? So we're going to talk tonight about some of that, but I want to go to one other report before we do, and that's the National Climate Assessment Report. This is a U.S. report, and it's congressionally mandated on climate change. The links are here, and by the way, in your handouts, there is a handout that hopefully you can get to in your GoToWebinar control panel. There's a handout there that lists these resources that we're talking about. So the National Climate Assessment Report came out on Friday after Thanksgiving. And if you go to the report, it's an amazing report. And even though it's based on the United States, there's a lot in this that international audiences can use. If you click on the chapters, it has a drop-down menu that shows what's in this report. And I'd like to point out for our international listeners that the national topics on the left side, also, there's quite a few of them that are really global in nature. For example, our changing climate and coastal effects and oceans and marine resources are really global in nature. There's another part of this report that looks at specific regions in the U.S. And so wherever you are in the United States, I recommend highly that you go and take a look at this. Like Mary said, I live in Florida, so I'm in the Southeast region, and I'm going to take you out to the website now and show you a little bit about this report. If you go to the chapter on the Southeast as an example, and you scroll down, you'll see that there are key messages specific to each region. It gives an executive summary, and as you do scroll through, well, you're supposed to have a little pop-up over here. There it is. There's a pop-up section that that shows this section's table of contents. So the key messages for my area and for the whole southeast of the United States are urban impacts, coastal flooding, ecosystem impacts, and rural impacts. It gives a lot of background, and with each of these sections, it talks about the science and gives a lot of background information. But what I also want to show you is as you go through these sections, they give case studies. And I think these are case studies that all of us can use if we're looking to our region and our local governments and decisions being made in our areas. These are some case studies that are currently happening and can give us some background to help us think about what we can do for where we live. This particular one is on Charleston, South Carolina. They have a crosstown parkway that has been susceptible to flooding events, that there's been 50 days of flooding in 2016, and they're predicting that by 2045 they'll experience up to 180 high tide flood events a year. Now, they estimate that each flood event, every single one of those flooding events, has cost $12.4 million. So Charleston decided to put a bunch of money into infrastructure. So they came up with $235 million to complete drainage improvement to prevent current and future flooding. Now, $235 million probably sounds like a whole lot of money to taxpayers until you point out that they've already lost $1.5 billion in damage and lost wages. So I think these case studies can really help us out as we're talking to people. Now, I told you that I was feeling really kind of hopeless when I heard the IPCC dire warning, and then I found Project Drawdown, and this is a resource that I hope all of you will check out, and if you're so inclined, begin to share it with your neighbors and your friends, and if you're out talking about climate change, share this, because this gave me so much hope. I got really excited about this. And I want to take you to their website. It's a pretty simple website, but I think you should know what's here. Drawdown says they have 100 solutions to reverse global warming. And if you scroll down, they also have a book which says the most comprehensive plan ever proposed to reverse global warming. Now, I bought the book and I have it all highlighted and Post-it notes stuck in it, but you don't need to do that. Everything is on this website. So Drawdown Drawdown defined as that point in time when the concentration of greenhouse gases in the atmosphere begins to decline on a year-to-year basis. Now, remember, this book said the most comprehensive plan ever proposed, but what they say is we did not make or devise the plan. The plan exists and is being implemented worldwide. So they got together a whole bunch of international scientists and asked them to research the 100 best solutions to climate change. And that's what this list is. And I think this is really important. And down here it says the solutions we modeled are in place and in action. Humanity's task is to accelerate the knowledge and growth of what is possible as soon as possible. If you go down to the bottom of the page, they have a lot of videos down here. This particular one takes you through the steps that how the scientists came up with their list of 100, and it's very impressive. They also have this one. One of the 100 solutions are organized by sectors. In other words, they're categorized by sectors, and we'll talk a little bit more about that. But one of the sectors is women and girls. And this one really surprised me. So I recommend you watch that video and read and hear about that sector. If we go back up to the top, there are these three little lines next to the icon Drawdown, and when you click on it, it lists things that are on this website. And then click on the solutions. And I really want to show you this because it'll help you navigate a little bit. But as you go down the page, it gives you an introduction to scenarios, the summary of solutions by overall rank, and then the sector summaries. So these are the categories: electricity generation, food, women and girls, buildings and cities, land use, transport, and materials. They set up all 100 solutions by rank. So starting with number 1, it gives the sector, how much atmospheric CO2 can be reduced either by sequestering it or stopping it from being put into the atmosphere, how much it'll cost, and how much it will save. Now this is where I got really excited. In the top 10 solutions, you know, I was so worried about the fossil fuels and being able to get off those fossil fuels quickly. There's only 3 in the top 10 that are solutions that have to do with electricity generation and that fossil fuel use. 2 are women and girls, and they say that if you put these 2 together, it's the largest carbon dioxide eliminator from the atmosphere. So that's helpful. The thing that also got me excited is there's a lot of food sector ones. And these are things like reducing food waste, plant-rich diet. Those are things that each of us can do and should do. And refrigerant management within our own appliances is being very aware of that, and then working with our local communities to make sure that we're all doing all of those things. If you go farther down the page, you can choose the sector and it will have all the solutions within those sectors. And then if you go on, these are each of the solutions in alphabetical order, and then it also tells the sector. So this is exciting to me. There's a lot of meat to this. I've just begun getting into it and have gotten really excited about it. The second one is related to Project Drawdown, and that's Project Drawdown Eco Challenge. So the Eco Challenge is also has a website, and the Eco Challenge runs from April 3rd to April 24th. If I was still in a classroom, I would definitely be having my students and their families get involved in this Eco Challenge, but I'm going to do it as an individual too, and tell you about it and hope you'll do it with me. So they have featured challenges down here, and just to show you how it works, they list actions that you can sign up to do. So you can see these here: spreading the word about energy alternatives, and all of that. And then this is one that I actually did last Friday, rooftop solar consultation. I had a solar panel installation come out and look at our house and give me all the information that I'm still looking into, but we've already decided we're doing this, and we're doing it this year. So oops, let me go down, let me go back up here. So all of these are things that you can do. The women and girls, one of the things that I thought was interesting was supporting women-owned businesses. I will spend however many minutes each day researching women-owned businesses I can support when shopping. So these are all things that I can do easily and will do in the Eco Challenge. And I hope you'll join me. So, whoops, I think I skipped. No, I got that in the wrong place. Sorry about that. I just wanted to talk for a second about the class, which starts the 4th of March. If you go to polareducator.org, there's the Masterclass tab and then Ice Core Science, and in that page, there's a register now, and you'll get invited into the class. And the class is has a couple of messages up that you can respond to and share on. One of them is to write a webinar response as one of the items on the syllabus. And if you go to this Ice Core Science and Masterclass on the Polar Educators page, you'll see the whole syllabus, and we hope that you'll join us.
Thanks so much, Louise. So much good information.
And so then that's it for me. Thank you.
I've got a couple of comments that I wanted just to read to the group. Betsy was talking about Project Drawdown, providing the dream for the future. Catherine Wilkerson, editor of the project, said that if Martin Luther King started this movement, his movement, with an I have a nightmare, nothing would have been accomplished, which is so true. Another comment from Betsy, she spoke with one of her teachers who was a Drawdown fellow. They're building resources for education, and there's going to be an REU this summer at Penn State, and undergraduate students will be helping with this. And one more comment, there's still a plan with Drawdown to make data available on their website. Let me see. Anika, she had a question. Let me see, hold on, let me get to the right question. Louise, she said, I love this data. It's very strong. How is this created with the EPA not recognizing climate change? How is this being funded with this administration denying climate change?
Hi, Anissa. I'm glad you're here. I'm not sure I understand the question. Or if we're talking about Project Drawdown and how is it funded, to be perfectly honest, I don't know, but Betsy might. And I love that Betsy said we can have a PEI team. Yeah. So I don't know if I can find out, and maybe that's something we can talk about in the master class, or send me an email and I will find that out.
Might be a good thing to talk about in the Google group. And also, I love that she's already saying she's going to get her green team at school, and Betsy's saying, let's have a PEI team. There's already some enthusiasm. Those kinds of ideas can be shared in the Google group.
Yeah, and I think, like Mary pointed out, we can't wait for policy. So even if the EPA or the administration's new climate change group doesn't help us move forward, we can move forward ourselves, and our local regions and governments work with them. There's lots of things going on around the country, and I think that's what we need to focus on, are the things that are happening, and not worry too much about the things that aren't happening.
Okay, just want to bring a few things to your attention. Louise was talking about those additional resources. As she mentioned, the handout is available in the GoToWebinar control panel. There, it says handouts 1 of 5. We'll also be putting this up in the Google group. The resource links, the few that you see on the screen right now, are some that Louise introduced in the webinar, but they're not limited to that. She's got a lot more on that list that you can access, which is great. So they'll be shared on the PEI group Facebook page and also in that Google discussion group. So for the master class, a few reminders. We want you to make sure you join the online discussion as part of our Google group. I've been sending out invitations every day to people that have registered for the webinar. The discussion forum will take place from the 4th through the 15th, as Louise mentioned, to give people a little bit of a chance to watch the webinar, those that could not be with us tonight because of conflicts or time zone issues. If you want to earn a PEI certificate of participation for 6 contact hours, for those of you looking for professional development hours, you either attend the live webinar or view the archived webinar, okay, and post a short response. Actively participate in the online discussion in the Google group, including the required posts as outlined in the course syllabus, which, remember, you can get to that on the PEI website under the Masterclass tab. You can see that detailed syllabus on the website for different readings and videos that Louise and Mary have suggested. We hope that you've completed the pre-survey per my reminder yesterday that I sent out, and then later on take the post-survey. And then also at the end, post a short description of how you will empower your students or colleagues. I put colleagues as well, because it might not be that you have students, but you can influence your family or your colleagues or your friends to take action. And before I sign off, I wanted to also, hold on one second. Betsy had asked me to show, if I can get out of there. There we go. Wanted to bring your attention to some featured news on the PEI website. We've got a conference, PEI in the UK, coming up in April. between the 8th and the 11th of April in Cambridge. It's Education in Polar Science, bringing the polar regions into our communities. So the registration is open at this point. You could submit a poster or presentation proposal. There's a program available, and there's housing and visitor information, and all of that can be accessed through the PEI website. So I urge you to go onto the PEI website and take a good look at that. Okay.
And Betty, there's
Yes.
one comment asked if schools from Australia are able to enter the challenges in Drawdown. Drawdown is definitely internationally focused. So yeah, I don't think there's any doubt about that.
Okay, awesome. Okay, well, thank you so much for joining us tonight and taking part in PEI's Masterclass series. And please refer to our website. If you're not already a member of Polar Educators International, please join us. It's a really vibrant community of educators and scientists working together. And we'll be having another masterclass later on in 2019. I'll look at the questions just one more time. Let me see if there's any others. Betsy had remarked that NOAA and all the scientists that have contributed to NCA report are still moving forward. So,
Yeah,
okay.
thanks for that, Betsy. You're right.
And Ingrid, yes, you absolutely can enter that challenge and Drawdown. So if there are no other questions, I want to thank our presenters, Dr. Albert and Louise, tonight for doing a great job. And the archived webinar will be available within the next couple of days on the PEI website. So thank you so very much for attending tonight.
Thanks, everybody.
Okay, thanks.
Thank you. Okay, thank you. I'm going to sign off.
I'm just
Okay, Mary, thanks so much.
Louise, how do I
Okay.
stop the recording? I can't find that.
Under sharing, I just turned it off.
Did
Now,
you turn it off?
I did. Betsy is not signed in as an organizer, so
It says it's still being recorded.